Okay, so for the next one, for this one right here, we have something different. We have this square root sign right here. All right, now I'm going to keep it really simple. I'm going to kind of simplify the explanation for this one. We're taking the limit as x approaches infinity, x squared over x to the third plus 1. Sorry, it looks all tiny on my screen. Okay. If we were to plug in infinity, just talk about what happens. The top would go to infinity. The bottom would also go to infinity. Okay, even though we square root it, it's still going to go to infinity. So we have to manipulate this. Now, whenever you have a square root, the denominator, in this case, has a square root. It behaves the same way as like a rational exponent would. Or, no, it's not coming out right. Here, let me say this. Let me remind you guys of this. If I have x to the third, and we're taking the square root of that, how can I write that as just a power, just an exponent, yeah? Yes, because this is the square root, you can rewrite this as x to the third over 2. Okay? So this right here actually behaves just like this. I mean, there's a slight difference because there's a plus 1. So it shifts it a little bit, but it doesn't change the shape of the graph as much as the behavior. So what we're going to do is we're going to instead take the limit as x approaches infinity of x to the 3 over 2 and x squared up top. So this right here we can do, and it doesn't have this nasty looking square root sign right here. This is going to behave the same way as this. So how can we, like what would we multiply the top and the bottom by to find out what's happening here? 2? X to the negative 2?
Yeah.
X to the negative 2?
Wait, Mr. Patey.
Yeah.
Where did the 1 go?
Where'd the 1 go? The 1 is kind of insignificant right now because once we do this, this 1's going to go away when we take it to infinity. Okay? I'll show you the long explanation after we finish this part right here, and it'll make sense to you. Okay? So what do I get on top? I get x to the 0, and on the bottom I get, well, if I make this have the same denominator, that'll be 4, negative 4. So what's negative 4 and 3? 1. What? X to the negative 1 over 2. Okay, now this isn't good because now we have 1 over x to the 1/2. And what's this going to go to when we take it to infinity? It goes to 0. Okay, so that didn't work. Let's not multiply by x to the negative 2. Let's multiply by something else.
Negative 3 over.
Yeah, you want to do that one? That's a good idea. Okay, so let's do it instead by negative 3 over 2. Ooh, let's see what happens. What's that? There is, but we are ignoring it right now and saying that this denominator behaves the same as this denominator. And I'll show you guys why in a little bit. Okay, so this one is going to be x to the, let's see, that would be 2, so this would be a 4 right here, so it's going to be 1/2. Is that right? You guys good? Am I good? And the bottom I get x to the 0 power, which is just a 1, right? So we have 1 on the bottom, and we have x to the 1/2 up top. And don't forget, we are taking the limit as x approaches infinity. And what is that going to equal in this case? It's going to be infinity over 1, right? Which is just infinity. So that's our answer. But how can we do that? How can I just ignore this 1/2 right, or this plus 1 right here? You guys ready to go on a ride? Because this is kind of getting gnarly. You ready? Okay. All right. Just do it, man. Okay. So we're going to look at this right here, and I'm going to factor out, on the inside, I'm going to factor out an x cubed. This is like algebra manipulation in its rare form. We have x to the 3rd power, and that's going to be times 1 plus 1 over x to the 3rd. And that's all inside of this radical. I know some of you guys are going, what the? Okay. Now, when we factor out an x cubed from this x plus 1, we're dividing that by x cubed, and then we're dividing that by x cubed, right? So I get 1 for the first one, because x cubed divided by x cubed is 1, and then 1 divided by x cubed is 1 over x cubed. So when I have two things multiplying to each other inside of a square root sign, guess what we get to do? We get to split it up. I know you guys were excited about that. Okay, so we have x to the 3rd square root of that, and then we have the square root of 1 plus 1 over x to the third. Okay, so this is, I mean, it's looking a little better, but it's still kind of nasty. Let me get this other stuff here and shrink it up. Bam. So we have space. Okay, so now this I can translate because you guys did it right here. So this is x to the 3 over 2, and then we have stuff going on inside of that radical, then we have x to the second power. Now, we're going to do the same thing that we did right here and multiply the top and the bottom by x to the negative 3 over 2. So we do that over here. Now, what's that going to do to this stuff in here? If I multiply x to the negative 3 over 2 to this, do I multiply it to both of these or just one of them? Check it out. If I went 5x and I multiply this by a 2, do I multiply the 5 and the x by the 2? Or do I just go 5x times 2? 5x times 2. So when I have two things multiplying to each other, you just multiply one of them by the number, right? So I don't have to multiply both of these by the negative exponent. I just have to multiply one of them. Okay? Here, let me pause and clean this up. So here it is, and we would multiply the top by x to the negative 3 over 2, and the bottom by x to the negative 3 over 2. Now we don't have to multiply this by this. We just have to multiply one of these by that. So I'm going to multiply by that guy because he looks way nicer. What's x to the 3 over 2 times x to the negative 3 over 2? X to the 0. So we have x to the 0 on the bottom, and that's multiplying times the square root of 1 plus 1 over x to the third. And on the top, what do I get? We did that already. What is x squared times x to the negative 3 over 2? What do we get over here? X to the 1/2? And so now I'm taking the limit as x approaches infinity. And so check this out. This is just a 1, so that x isn't really there. The top goes to infinity, right? Right? The top going to infinity? And then what's happening to this right here? Because he has a variable. What happens to this 1 over x to the third? Yeah, this guy goes to 0. And so I have the square root of 1. What's the square root of 1? And then times 1. So we still get infinity. It's just nastier that way. So really, the only thing that matters right here inside of the radical is the term with the highest degree. Okay? And you can factor out and get all nutso with it to like logically prove it, but it's not necessary. You just have to know how this right here behaves. It's going to behave the same way. Okay? You guys good?